All right, we're going to take a look at momentum and impulse today. The equations that you're going to use are momentum. Momentum is represented by little p. It's mass times velocity. Mass being a scalar, velocity being a vector. We're also going to take a look at impulse. Impulse momentum theory is very similar to work energy theory or theorem, and the impulse is your force times your change in time is equal to your change in momentum. Right, and our change in anything is going to be our final of that thing minus our initial of that thing. The units for momentum, being a new variable we're working with, is kilogram meters per second. The units for impulse are going to be Newton seconds, right, force times time, or kilogram meters per second. All right, let's take a look at number 1. What happens to our momentum if we have twice the mass and the same speed? So if my original momentum was 24, I will do it like we did before. 1 times 1 is 1. So originally, we look at a base equation, and then if we have twice the mass, keeping the same velocity, we're essentially doubling our momentum. So if we started with 24, our new momentum is going to be 48. The same mass, twice the speed, same mass, twice the speed. Right, it's going to have the same effect. We're going to double our momentum. 1/2 the mass. Here, I should say mass times velocity gives us our momentum. And twice the speed, right? 1/2 times 2 gives me 1. So my momentum would end up staying the same, and so on. So try the rest on your own. And I'll do a few of these. So according to the Guinness Book of World Records, the fastest baseball pitch was delivered by Nolan Ryan in 1974. The pitch was clocked at 100.9 miles per hour. We want it in meters per second. So our velocity is going to be 45 meters per second. Determine the impulse required to give this ball with a mass of 0.145 kilograms such this momentum. So my momentum is mass times velocity, right, is also equal to my impulse. My change in momentum is equal to my impulse. So this initial momentum of the ball before it gets thrown is going to be 0. So we're really just looking for our mass times our velocity. So in this case, it's going to be 45 times 1.545. 6.525, and this is in kilogram meters per second, or you could also do in Newton seconds. Let's try number 3. We've got a linebacker at Tech's varsity football team against a crosstown rival Armwood has delivered his hit to a 92 kilogram running back. So this will be my mass. Changing its eastward velocity, so my initial velocity is going to be 5.6 meters per second. Now I'm going to identify this as positive because it's in the eastward direction, into a westward velocity. So my final velocity here is going to be negative because I'm going westward. So these are all my variables. So determine the initial momentum of the running back. So my initial momentum, my mass times velocity, is going to be 82 times 5.6 459.2. The final momentum of the running back. Determine the change in momentum. So my change is going to be my final minus my initial. But if this is my initial momentum, this is my final momentum, I will subtract the two. So my final is negative 205 minus my initial, which is 459.2, gives me a change of negative 664.2. Okay. Determine the impulse delivered. This is a conceptual problem, right? Because our impulse is equal to our change in momentum, which we already identified to be negative 664.2 kilogram. All right, let's find one that has force and time in there. Let's do number 8. While playing basketball in PE class,